Well, hello, ladies and gentlemen. It's week 5. We are into the 5th week of school at this point, and this is the second unit in geometry. And in this second unit, we're covering logic, and we're covering logic and reasoning and trying to make certain we understand how to write proofs and what proofs are. Okay? So, where should you all be? Unit 1 should be done. That was last week. You should have completed everything in Unit 1 and done the unit exam and done the unit part A and part 1 and part 2 and got those both turned in to me. If I haven't got it graded yet, I'm working on them as quickly as I can. As soon as I get them done, I will get the grade to you. Okay? Now, just to let you know what's going on. Week 5 is normally where I would go back to week 1 and put zeros or make the zeros that are in week 1 permanent. Now, there were no assignments in week 1 that you need to worry about, so don't worry about week 1. There wasn't anything out there. If you're a late starter, don't worry about it. Those zeros won't happen until you've been here and at least 4 weeks, okay? So we're into week 5, so that's just for the people who have been here since the day that the school started. Okay, going forward. We're in Unit 2. In Unit 2, we're writing conditional statements. A conditional statement is nothing more than an if-then statement. If A, then B. That is a conditional statement. What you see on the screen there, it says a bear is a carnivore. Can I write that as an if-then statement? If an animal is a bear, then it is a carnivore. It was an English transformation. You didn't know you were going to be doing English in geometry, now did you? Well, guess what? That's what we are doing. We're going to be taking statements and turning them into conditional statements, if-then statements. Why? Well, let me just tell you. Most of math is written by people who were French in nature. A lot of the great mathematicians were French. Before that, they were all Greek. Those languages are written differently than English. So, when we write a sentence that makes perfect sense in English, it doesn't make perfect math sense. So we have to turn it into a math statement. And the math statements are written in if-then format. That's why we're going to be dealing with conditional statements. Okay, so let's look at some forms of a conditional statement. It says, write all forms of the original conditional statement. If an animal is a bear, then it's a carnivore. Well, that's a conditional statement. I just told you, if it starts with an if and it has a then in it, it's a conditional statement. That means that is a conditional statement. What do you mean by the forms of the conditional statement? Well, we can take that if-then and we can turn it around. This is where, if you're dyslexic, it helps a lot, because we're going to take what's here at the end, the then, and we're going to make it at the if. And we're going to take what's here at the if and put it after the then. We're just going to swap it around a little bit, and we're going to call that the converse. If an animal is a carnivore, then it is a bear. Can you see how that is just swapping the ends? All we did was take what was in the if statement and turn it into the then statement. Take what was in the then statement and turn it into the if statement. All I'm doing is swapping them around. This is that old mind trick where you take one shell on one side and another shell on the other side and you swap their locations. That's all it is. I just swapped their locations, okay? Just take the entire statement and swap it. Inverse. Inverse, I'm going to take the word not. This was very popular back in the 90s, 2000s, was for someone to sit there and say the word not. Well, that's not what we're doing. We're taking the word not and sticking it into the original conditional statement. So if a bear is not, if an animal is not a bear, then it is not a carnivore. That's the inverse statement. And the next part of this is the contrapositive statement. And I'm not certain you can see that. Let me get to here. Contrapositive statement. The contrapositive, I'm going to do both. Take the converse and the inverse. Does it matter which one you do first? No. Does it matter how I do it? No, not really. As long as you stick the word not in both of the two, the front and the back of the if-then statement, and you swap their locations, you will wind up with the contrapositive. So, if an animal is not a carnivore, then it is not a bear. Mr. Green, sounds like a double negative to me. Yep, it is a double negative. And yep, that's valid in other languages, not in English, but you know what? That's a valid contrapositive statement. Interesting fact that you need to understand. If the conditional statement is true, then the contrapositive statement will be true. Every single time it works out that way. If this one is true, then this one is true down here. Oh, I just wrote a conditional statement. If the conditional statement is true, then the contrapositive statement is true. Works every time. Those two are considered logically equivalent statements. I could show you using logic tables, but it escapes me sometimes too. So the true answer here is just memorize that fact. Conditional statements, contrapositive, have the same truth value. Well, what about the converse and the inverse? A lot of times those will be the same, but there are conditions where they are not. So you can't really say anything about it. And what you have to do is go into a truth table situation and try to work them out. A little bit beyond me, but I will believe you. All you have to do is say, I need to work out the truth of the converse and the inverse, and that will do it. Why am I telling you you have to say that? Well, guess what? In the part 2, in the unit 2, this is one of the things that you will have to do. So you need to be prepared to write the four types of conditional statements, the 4 forms of the conditional statement, and talk about the truth. If the conditional statement is true, what else do you know? Well, you know the contrapositive is true, and the converse and inverse might be true, but you got to prove them with some sort of a diagram. Speaking of a diagram, one of the types of diagrams we can use is called a Euler diagram. Yes, that is Euler. I know. French can't learn to spell anything right, but guess what? That is the name Euler. Mr. Euler came up with this nice little way of drawing an if-then statement. When you see a statement like this, P then Q, so that's if P then Q. Okay? If P then Q, the P goes in the inner circle. The Q goes in the outer circle. And it's that simple. The if goes in the inner circle. The Q goes in the outer circle. The then goes in the outer circle. All you got to do is do it that way. Makes sense to me. Okay? So what does that do to the inverse and converse? Well, sometimes it really makes some really ugly circles. But that's one way that you can try to prove it. Don't try to do it if you don't really feel like getting into trouble. Okay, here's a situation. Create the Euler diagram. If an animal is a bear, then it is a carnivore. Bear goes in the middle, goes in the small circle, B-E-A-R, and carnivore goes out here. You're getting the idea, even though I can't spell. Right? Carnivore. Bear, carnivore. Guess what? There are other animals that are carnivores that might be over here. But it wouldn't make sense if it were the other way around, because then these other animals wouldn't fit inside the circle that's the bear, so that's why this works. Okay? Cool. Hope you guys recognize that. So, we're going to be talking about some other types of things called compound conditional statements. This is typically where I break out that video. Wait a second. I've got that. There it is. Thought I knew I had this. Here we go. All together now.
I got and, but, and, or. They'll take you pretty far. And, that's an additive, like this and that. And then there's but. That's sort of the opposite. Not this, but that. And then there's or, O-R, when you have a choice, like this or that. And, but, and, or gets you pretty far.
Okay, so did you catch that? And, but, nor. Well, we're only going to talk about two of them. And is a conjunction. It joins two things together and they add together. And, okay? And then disjunction. That is an or. Okay? This or that. Kind of like it subtracts, doesn't it? Almost, but not quite. This or that. These are the two types of things. So when you're asked, here's a conditional statement. Where is it a conjunction or a disjunction? Well, guess what? If it's got an and, it's a conjunction. If it's got an or, it's a disjunction. If it has both, you're confused. So would I be. But trust me, that's the way the logic works. So, inclusive or and exclusive or. Rah. Inclusive or means this one or that one. Exclusive or would not allow you to have both of them be true. Inclusive would include it. Exclusive would not. Okay? For example, I could ride the bus or I could take a taxi. I can't be in two places at once. I got to do one or the other. That would be an exclusive or. How about this one? I could eat a Butterfinger or I could eat a Milky Way. Well, I could do either one of them or I could eat them both. I'm that kind of greedy person. So that would be an inclusive or. It depends a lot upon what you're doing. If it's something that physically you can't be in two places at once, it's exclusive. If it is not something like that, then it could be an inclusive or. You just have to know the situation that you're looking at. So, indirect proof. Knew we were going to get to this eventually, didn't we? An indirect proof, you begin with the conjuncture, you negate the conjuncture, assume that it's false, show that this leads to a contradiction, and then your conclusion must be true or must be false because you ran into a contradiction. Therefore, the original conjecture must be true. Huh? Well, let's try it this way. I'm going to begin with the conjecture that all cabs are yellow. I'm going to negate that conjecture. All cabs are not yellow. I'm going to go look at the cab company, and guess what? All the cabs I see are yellow. Okay, that's okay. I'm liking this so far, and then I walk outside and I see this white cab go by me. Guess what? That proves the negative conjecture. That means my original conjecture must not have been true. It must have been false. Okay, I can see that, right? How about begin with the conjecture? Ripe bananas are yellow. Negate the conjecture. Ripe bananas are not yellow. I'm going into my kitchen and I find a banana that is black. I'm going to see if it's a ripe banana, and it is not a ripe banana. That must mean that my conjecture that I said that I negated was false. Therefore, the initial statement was ripe bananas are yellow. They must be yellow. Okay? Do you see how I used that indirect proof? I kind of went backwards at it. I said I'm going to start out, here's the statement, I'm going to start out negating it, and once I negate it, if I reach a contradiction, then I know I must have something wrong. How does this work in math? Well, we know certain things to be true, don't we? We know that 1 plus 1 is equal to 2. So if I negate something and I wind up down at the bottom that 1 plus 1 is equal to 3, I've run into a contradiction. Therefore, my original negation must have been wrong and the original conclusion must be true. It works that same way. That's what we're going to be doing when we're doing proofs, is trying to reach that contradiction sometimes. That's one method of doing it. Okay? Counterexamples. A counterexample is if someone makes a statement that they're wanting to prove. If you can find one counterexample that proves it to be false, then you can say it is not a true statement. Example, if the conjecture is all race car drivers are male, you can go look up this lady, Janet Guthrie. You can go look up any one of the female race car drivers and prove that this statement is false. Therefore, the conjecture is false. Isn't that easy? All you got to do is find that one counterexample. So what have I been doing here? I'm trying to develop an awareness of structure in mathematical systems, connecting definitions, postulates, logical reasoning, and theorems, determining the validity of a conditional statement, its converse, inverse, and its contrapositive. That's what I was trying to do with this lesson. Sorry it took so long, but that's the way these proof lessons go. And I want to make certain you guys remember Make certain you're telling me the section number when you're sending me things, so it will help us get communications going a little bit faster. And I am looking forward to the rest of